T presents audiobook of Geography for Class 6 entitled The Earth, Our Habitat. Lesson 3 Motions of the Earth. As you know, that the Earth has two types of motions, namely rotation and revolution. Rotation is the movement of the Earth on its axis. The movement of the Earth around the Sun in a fixed path or orbit is called revolution. The axis of the Earth, which is an imaginary line, makes an angle of 66.5 degrees with its orbital plane. The plane formed by the orbit is known as the orbital plane. The Earth receives light from the Sun. Due to the spherical shape of the Earth, only half of it gets light from the Sun at a time, as shown in figure 3.2. The portion facing the Sun experiences day, while the other half away from the Sun experiences night. The circle that divides the day from night on the globe is called the circle of illumination. This circle does not coincide with the axis as you see in the figure 3.2. The Earth takes about 24 hours to complete one rotation around its axis. The period of rotation is known as the Earth Day. This is the daily motion of the Earth. Figure 3.1 shows inclination of the Earth's axis and the orbital plane, wherein we see the North Pole and the South Pole. Also, the plane of the Earth's orbit. It has also been marked the Tropic of Cancer, Equator, Tropic of Capricorn. The figure also shows the vertical line from the Earth's orbital plane. Figure 3.2 shows day and night on the Earth due to rotation. Here we see the sunlight, the North Pole, the South Pole. We also see circle of illumination, equator, and axis. Let's do. Take a ball to represent the Earth and a lighted candle to represent the Sun. Mark a point on the ball to represent a town X. Place the ball in such a way that the town X is in darkness. Now, rotate the ball from left to right. As you move the ball slightly, the town will have its sunrise. As the ball continues to move, the point X gradually gets away from the Sun. This is sunset. What would happen if the Earth did not rotate? The portion of the Earth facing the Sun would always experience day, thus bringing continuous warmth to the region. The other half would remain in darkness and be freezing cold all the time. Life would not have been possible in such extreme conditions. The second motion of the Earth around the Sun in its orbit is called revolution. It takes 365 1/4 days, that is 1 year, to revolve around the Sun. We consider a year as consisting of 365 days only and ignore 6 hours for the sake of convenience. Do you know? The ancient Indian astronomer Aryabhat had stated that the Earth is round and rotates on its axis. In figure 3.3, you can see revolution of the Earth and seasons. In the center, we have the Sun. The Earth is shown rotating on its own axis as well as revolving around the Sun. So, as per the diagram, we see summer in the northern hemisphere and winter in the southern hemisphere. Summer solstice, 21st of June. We also see autumn, spring, equinox on 23rd September. Further, We see winter in the northern hemisphere, summer in the southern hemisphere. That is winter solstice on 22nd of December. We also see spring, autumn, equinox, that is on 21st of March. The diagram clearly explains revolution of the earth and the kind of impact it has on the season change. 6 hours saved every year are added to make one day, that is 24 hours, over a span of 4 years. The surplus day is added to the month of February. Thus, every 4th year, February is of 29 days instead of 28 days. Such a year with 366 days is called a leap year. Find out when will the next leap year be. From the figure 3.3, it is clear that the Earth is going around the Sun in an elliptical orbit. Notice that throughout its orbit, the Earth is inclined in the same direction. A year is usually divided into summer, winter, spring, and autumn seasons. Seasons change due to the change in the position of the Earth around the Sun. Page number 20. Let's do. Do you know how to draw an ellipse? Take a pencil, 2 pins, and a loop of thread. Now, fix these pins on a paper as shown in the figure. Put the loop on the paper enclosing these 2 pins inside the loop. Now, hold the pencil and draw the line, keeping the thread tight and moving the pencil along it. The figure represents an ellipse. Look at the figure 3.3. You will see that on 21st June, the northern hemisphere is tilted towards the Sun. The rays of the Sun fall directly on the Tropic of Cancer. As a result, these areas receive more heat. The areas near the poles receive less heat as the rays of the Sun are slanting. The North Pole is inclined towards the Sun, and the places beyond the Arctic Circle experience continuous daylight for about 6 months. Since a large portion of the northern hemisphere is getting light from the Sun, it is summer in the regions north of the equator. The longest day and the shortest night at these places occur on 21st June. At this time in the southern hemisphere, all these conditions are reversed. It is winter season there. The nights are longer than the days. This position of the Earth is called the summer solstice. On 22nd December, the Tropic of Capricorn receives direct rays of the Sun as the South Pole tilts towards it. As the Sun's rays fall vertically at the Tropic of Capricorn, that is 23.5 degrees south, a larger portion of the southern hemisphere gets light. Therefore, it is summer in the southern hemisphere with longer days and shorter nights. The reverse happens in the northern hemisphere. This position of the Earth is called the winter solstice. Do you know that Christmas is celebrated in Australia in the summer season? On 21st March and September 23rd, direct rays of the Sun fall on the equator. At this position, neither of the poles is tilted towards the Sun. So, the whole Earth experiences equal days and equal nights. This is called an equinox. On 23rd September, it is autumn season in the northern hemisphere and spring season in the southern hemisphere. The opposite is the case on 21st March. Let's do. To understand the Earth's inclination in the same direction, draw a big ellipse on the ground and take a flag with a stick. stand anywhere on the line of the ellipse. Point your flag to a fixed point far away, like on a treetop. Now, move along the ellipse, keeping your flag always pointing towards that fixed point. In this way, the axis of the Earth remains inclined permanently in the same position. The revolution of the Earth and the inclination of the Earth's axis in a fixed direction cause seasons. Page number 21. When it is spring in the northern hemisphere and autumn in the southern hemisphere. Thus, you find that there are days and nights and changes in the seasons because of the rotation and revolution of the Earth respectively. Exercises. 1. Answer the following questions briefly. A. What is the angle of inclination of the Earth's axis with its orbital plane? B. Define rotation and revolution. C. What is a leap year? D. Differentiate between the summer and winter solstice. E. What is an equinox? F. Why does the southern hemisphere experience winter and summer solstice in different times than that of the northern hemisphere? G. Why do the poles experience about 6 months day and 6 months night? 2. Tick the correct answers. A. The movement of the Earth around the Sun is known as 1. Rotation, 2. Revolution, 3. Inclination. B. Direct rays of the Sun fall on the equator on 1. 21st March, 2. 21st June, 3. 22nd December. C. Christmas is celebrated in summer in 1. Japan, 2. India, 3. Australia. D. Cycle of the seasons is caused due to 1. Rotation, 2. Revolution, 3. Gravitation. 3. Fill in the blanks. A. A leap year has dash number of days. B. The daily motion of the Earth is dash. C. The Earth travels around the Sun in dash orbit. D. The Sun's rays fall vertically on the Tropic of dash on 21st June. E. Days are shorter during dash season. Page number 22. Things to do. 1. Make a drawing to show the inclination of the Earth. 2. Record the timings of the sunrise and sunset at your place, taking help from your local newspaper on the 21st of each month, and answer the following. A. In which month are the days the shortest? B. In which months are the days and nights nearly equal? For fun. 1. Draw different shapes of ellipses by placing 2 pins nearer and farther using the same loop of thread. Notice when the ellipse becomes circular. 2. On any sunny day, take a straight stick that is 1 meter long. Find out a clean and level place on the ground. Place this stick into the ground where it casts a distinctive, sharp shadow. Step 1. Mark the tip of the shadow with a stone or a twig or by another means. The first shadow mark is always towards the west. See after 15 minutes and mark the tip of the shadow again. By then it would have moved a few centimeters away. Now, join the 2 points and you have an approximate east-west line. Step 2. Stand with the first mark to your left and the second mark to your right. You are now facing north. This fact is true everywhere on the earth because the earth rotates in west to east direction. An alternative method is more accurate but requires more time. Set up your shadow stick and mark the first shadow in the morning. Use a piece of string to draw a clean arc through this mark around the stick. At midday, the shadow will shrink or disappear. In the afternoon, it will lengthen again, and at the point where it touches the arc, make a second mark. Draw a line through the two marks to get an accurate east-west line.